Good morning, everyone. I hope you enjoyed the first part of this day as much as we did. So we're going to talk about hybrid monitoring and logging. But before we get started, I would love to ask everyone to stand up for a bit. Could you please stand up? All right. We're going to run a very quick survey. Those of you running StackDriver in production, you may sit down. Big number. All right. Those of you using multiple monitoring and logging tools in production, you may sit down. OK. And of the rest, those of you running monitoring across a cloud and some other environment, being on-prem or other cloud, you may sit down. Thank you. That was fun. OK, so here's the contract. Over the next half an hour or so, we're going to talk about what do we mean by hybrid, how do we let you monitor hybrid environments, and at the end, we're going to get you a great walkthrough of the features of a solution that lets you do so, and we are going to run a demo with a practical application. With this, let's get started. So when we talk about a hybrid environment, we're specifically thinking this very picture, right? You have a setup somewhere, be it on-prem, be it some other cloud, and set up in the cloud, like GCP. And what you really want to do is to be able to run your workloads in the same way and monitor them in the same way. So ideally, that would be the very same monitoring and logging solutions with the very same dashboards and very same alerts that you would apply here, and like here, meaning in the cloud, and on premises, so that you can monitor and see what's happening. But even more convenient would be a situation like that, where you have just one point in which you can compare how your system is doing, which is specifically important if you're running the workloads with some spillover between one and the other, and you really want to understand what's happening. More about it in a demo in a second. All right, so before we go there, just realize Kubernetes brought this enormous opportunity of doing exactly this, because the way of abstracting your workloads on top of the physical infrastructure lets you look at your deployments and your workloads in the exact same way. So how does the data flow from the darkest corners of Kubernetes? Let me get you a very quick walkthrough. First, Kubernetes per se does not have any sophisticated built-in monitoring and logging system. However, many components depend on monitoring data, right? So things like horizontal pod autoscaling, scheduler, kubectl top, and node itself, they need metrics. So this has been solved by Kubernetes, by itself, for itself, through something I would call metrics API. This way, horizontal pod autoscaling can actually work using some internal metrics on the CPU utilization. Scheduler can make a reasonable decision of where to place the pods, right? And kubectl top gets you the proper information of what's really happening. So the metrics API is implemented by the metrics server. Metrics server is technically scraping the nodes in the search for the metrics data. That's what's happening there. So let's have a look at the API. When you look at that, it's super simple, right? It actually has three components through the definition. And one is on the level of nodes, the second one is on the level of pods, and the third one is just a list of containers inside of that pod. And it really specifies only two pieces of information, right? A timestamp, a time window, and the usage data. So this is what we're collecting. This is what the metrics API is actually getting out of Kubernetes. Now, let's have a closer look what's happening at the node. Right? Well, at the node, you obviously have a kubelet. The kubelet is consulting with the C advisor to scrape the data from all of the system components, like Docker, like etcd, like all other pieces, like system-level pods that need to be monitored. And all of that data is then extracted into the summary API. So through this, well, we have a system that is self-sufficient. We call it a core metrics pipeline. This is the system that lets Kubernetes run. But in order for you to run the workloads, to run your setup, you actually need more than that. And for this, you need external solution. We call it third-party applications, right? These solutions, there are many of those. They work in one of two ways. They either work in a push model in which the data and metrics collected gets written directly to the monitoring solution, or they work in a pull model where the monitoring solution is scraping the data from the endpoints. It's hard to say which one is better. There are solutions that work either way, and we're going to walk you through both of these. So in order to look at the data, you can look at two possible solutions. We're going to walk you here through Prometheus and StackDriver. Prometheus works in the pull mode. StackDriver works in the push mode. So when you look at the structure of Kubernetes, you have the nodes on the bottom with kubelet, the key component of the control of the system. Then you have pods, and then you have Kubernetes master, right? At the node level, you have node exporter. Through node exporter, Prometheus gets the data of like what's really happening there, CPU utilization, amount of memory, all of that kind of stuff. And then there is pods. Pods, as we just discussed a minute ago, get the C advisor to go get all of the data of how pods are behaving. And on top of that, you have all of the natural components of the Kubernetes as a system that are naturally reported in the Prometheus format. And this is everything from the Kubernetes API through the containers runtime, kubelet status, etc. All of these components in a very natural and native way get reported by Prometheus server that sits on each and every node. So now that we have it, let's have a look at how this is happening in StackDriver. So StackDriver has a layer of 3 APIs. The first one is the StackDriver Monitoring API. It has a hipster through which it's collecting some of the data. But in fact, it also has a StackDriver Prometheus collector. So StackDriver Prometheus collector is capturing all of the data that Prometheus is scraping from all of the system components, like the whatever number of 500 errors, 200 errors, anything that is happening in the Kubernetes layer can now be accessible through the StackDriver. And then there are two more components. One is the metadata API that reads the data through an agent that gets deployed on each and every node. And the same deployment of a daemon set is also deploying another pod that is called StackDriver Logging Agent that is collecting the logs, right? So through this, you have a full set. This works in a push mode. And now when you look at that holistically, you have Prometheus clients that are on each and every node, and then you have two possible layers, two possible ways you can read your metrics data, right? The top one is the open source format. The Prometheus collector gets all the data, then it uses its own storage, and you can either present it either in Prometheus or in Grafana. I'm sure if you're using any on-premise solution, you're very familiar with this. And then you have StackDriver. StackDriver does the same, but it has the StackDriver Prometheus collector, so it collects all of the data from Prometheus. But on top of that, it's also getting some electric data and metadata, right? And again, you can say it in StackDriver Monitoring UI, or you can graph it in Grafana. So that's it. That's the story. And now, for the rest of the talk, I would like to invite to the stage JD Velasquez and Shuhong Cheng, who are going to talk about how we can see it in practice. That's for you.
Thank you, Jersey. Hello, everybody. So we want to tell you and give you a demo of how all of this works. But before we do that, let's try to orient ourselves a little bit. Before we go to the demos, put on the slides again, please. We'll try to orient ourselves a little bit on what application we have here, to give you a sense of what it is that we're doing. So this is a simple Java application some of you may be familiar with. It's a pet clinic. It's a veterinary clinic. Who here has pets? Come on, a lot more of you have pets, yes? But hopefully, your veterinary clinic is not using this application to handle everything inside because it's pretty buggy and it has other things, but we're going to try to solve those issues right now. So this is, again, like I said, just a simple pet clinic. Imagine that you're an employee on this veterinary clinic and you want to be able to handle the visits from all of your customers. They're pet owners, they have pets. And you want to track what sort of things they're doing, the types of visit, the type of veterinarians they have, and so on. So to orient ourselves further in this application, to really go into a hybrid scenario, what we've implemented here, to give you a sense, is an architecture like this. We essentially have a cluster that has been deployed on-prem, Kubernetes cluster. We have 4 microservices here, doing what they're supposed to do, managing customers, managing the visits, managing the veterinarians in general. And the same cluster we have actually deployed on Kubernetes Engine, on GCP. And both of those clusters communicate with the data source, which is Cloud Spanner. Okay? So that's essentially the app. Very simple. Now, let's go to the demo now, and we'll see this in action specifically. So just to orient ourselves a little bit further and to start to generate a little traffic to this app, let's go in and use it just a bit. Let's list the set of owners that may exist already. This business may not be doing very well right now since it has no owners or very few. Of course, it's a live demo. What could go wrong? Yes. There we go. OK, so we have a few owners already. What we can do is let's add a new pet to one of those owners. So we get a sense of the different services and what they do. Let's add a new pet to this particular one. Let's give it a name. We, of course, want to know the date of birth for that pet. And then a type of pet. I prefer dogs, but there's, of course, lots of cats. Now, we can add visits. We see that some of the pets for this owner, they've already visited the clinic and do some things. This new pet, we're going to take him in for the first exam. It's a physical exam, and that's it. Now, we may ask you, of course, to go in and generate some traffic for this, but instead of doing that, let us just generate a little bit of more traffic right now. The idea here is, of course, we want to scale up things so that we can do some of the troubleshooting scenarios. So we just are going to our on-prem cluster, and as you see here, we're just executing a scaling command, and we're just scaling up that on-prem cluster. Now, we did that on one side. Let's do it now on the GK cluster, on-prem Kubernetes engine. So let's go to our Cloud Console. Let's connect to the cluster. And when we do there, we see our Cloud Shell. Let's get all of our credentials properly. And now what we want to do is run the same command. We're going to scale up the Kubernetes engine cluster. So this is essentially what we need to do, right? Just generate some traffic here, and it would take maybe another a few seconds or so. There we go. Now, both clusters should be getting some traffic now. This is internally, but the same thing. You might as well be generating that traffic for us. Now, what we want to do is, what happens, how do we get the type of observability you need to see your Kubernetes environment, particularly in a hybrid scenario? So you can do a couple of things. If you're, if you're starting on-prem, most likely, like many of us, will be using open source software. So very likely you're probably using Prometheus and Grafana if you want to get metrics and do alerts and maybe some visualizations that you can configure and so on. And that's exactly what we're doing here. Now, if you want to get some logs as well, you may be using Elasticsearch or some other solution. And maybe you want other signals. So maybe a bunch of other tools. When Jerzy was asking you, those of you who actually have many tools, there was a large majority of you that actually stayed up and then came down when you actually use many tools all together to get this observability. So let's go to our Prometheus and Grafana instance on-prem, the one we set up. This actually took very little configuration. All of these solutions are available on our GCP marketplace, and you can just readily use it, kind of like a one-click type of setup, and get those running. So what we will do, and just cheating here a little bit to make sure that we get the right password, let's log into that Grafana instance that we have set up for on-prem. And as that comes in, OK, perfect. That's our Grafana instance. Now, out of the box, with this type of solutions, you get definitely some type of observability. If we look at the list of things here, we have several dashboards. You may look at your clusters, your namespaces, your pods, and so forth. Let's go specifically to our cluster one to get some notion of health that may exist here. So now you can see some particular scorecards. And definitely we see that traffic actually spiked up a bit, so our scaling is working. And then down below, we have some metrics that we could then further peruse. This is based on namespaces. I could go specifically to one of the namespaces. We go to the default one. And then from there, then we can drill down into pods. And maybe we have a dozen of pods or so for this particular app here. And then we can take a look at more of those metrics, CPU utilization, the limits, requests, and so forth. Maybe the same thing for memory, and so on. So this is the way in which if you're using open source and Prometheus and Grafana, you would get that type of basic observability you need for your on-prem cluster. But we're talking about hybrid. So you want to do the same for your Kubernetes engine. Now, there's now, you can have a do-it-yourself type of solution to do multi-cluster monitoring, but out of the box, you really must create a separate Grafana instance and put it on your Kubernetes engine side. And so let's do that precisely. Why don't we go to our Cloud Console, and then run the commands we need, and then logging into our Grafana instance for Kubernetes engine. Now, a good thing, of course, I can transfer all my dashboard configurations, and then we'll be there. So we can see the same thing. We have all the same type of dashboards. So let's do the same thing we did for the other one. Same type of scorecard, and we'll see the profile in a minute. Hopefully the traffic is working in the same way. And yeah, we see slightly different pattern, but traffic is also scaling up on the Kubernetes engine. And the same thing, we can scale down, drill down further on the default namespace, go to our pods. Again, the same type of observability that you would get. You can configure these dashboards as you wish, and then get something that meets your needs specifically. Now, as I said earlier, many of you actually are using many different tools to get the type of observability you need. And what we've heard from many of you actually is that you don't want to use that many tools, that you want a single unified solution to observe and get, do proper monitoring and logging of your Kubernetes environment, no matter where it runs. Whether it's running on-prem or running on GCP on Kubernetes engine, or even if you're running that Kubernetes deployment on a GCE instance, or maybe even on a VM instance on another cloud provider. You still want to have that single place where you can monitor all of these things. So this is where StackDriver Kubernetes Monitoring comes in. So StackDriver Kubernetes Monitoring gives you very rich and comprehensive observability for your Kubernetes environment, no matter where it runs. And what it does is actually integrates metrics and logs and events and metadata in a single place, so that you don't have to be going to different tools to try to get that observability precisely. And so let us see how this works in action. If we can go to StackDriver Kubernetes Monitoring, which you can do by selecting the monitoring link on your Cloud Console, that takes you to the StackDriver Monitoring console here. And from there, we're going to choose the Resources menu, and then go directly to the Kubernetes Monitoring console. So this is a product we just announced briefly, and it's in beta right now. And so we'd love for you to use it and give us your feedback. So first, this is the StackDriver Kubernetes Monitoring console. Let's orient ourselves a little bit here. So first, you see the event widget in the top. That allows you essentially to get information from different events, particularly things that may be of interest for your Kubernetes environment. It is actually a heat map. So you have the more solid lines is because there's a higher frequency of events. And the idea is for you to correlate those events with the state of your cluster down below. Now, in the pane below, precisely, you see the set of clusters. Now, from the start, notice that we already have observability of the two clusters. Our on-prem cluster is already there, and our GKE cluster is also there. Now, for deploying the StackDriver agents on the on-prem cluster, it's really simple. You just follow a set of instructions, and it's done. So out of the box, you get rich observability for your hybrid multi-cluster environment. Now, notice also that here in this scenario, we surface a lot of key information for you, including the number of incidents, pods that are ready, memory and CPU utilization with respect to your resources and the limits that you have configured. Notice as well that you've actually, even though Kubernetes doesn't have a hierarchy per se, we're taking advantage of Kubernetes labels to give you pre-curated hierarchies that may be useful for you depending on the role that you may have. So if you're an SRE and operator, for instance, you may want to look at the state of your infrastructure. You want to make sure that your nodes are healthy and performant. So that's what you may be doing here. But if you're a developer, you may actually want to be, and of course we want to, for you to focus on writing your code and look at your application. So you may be more interested in looking at it from the perspective of your deployments or your services particularly. So we can drill down from a cluster to a namespace to the services that you want. Notice as well that as we're doing this, you can actually drill down all the way from your cluster in all of these views, all the way down to a container. And for each of these Kubernetes objects, you get very rich information. So for instance, I can go and inspect, let's inspect a pod right now, and I immediately get several metrics. I know that my pod is ready and is running. If there's any incidents open, I can see it right there. And then I start to get some information on my metrics, like CPU, memory, and so on. All the way down, and notice that in the same place, as we move beyond network usage, you'll find that we also include logs. So that goes back again to this idea of true and rich observability, trying to increase the signals that are available to you at the right context, in the right time, and right Kubernetes component, so that it is easier for you to speed your root cause analysis when you're trying to resolve an incident, or to find things when you're just doing proactive monitoring. So we see snippets of logs already here, and I could even go deep down into logging to get more details here. Now, this is very much the self-contained Kubernetes monitoring, but of course you can use it with all the other features that StackDriver has. Jerzy mentioned before that StackDriver already has a Prometheus collector. So if you have a Prometheus instrumentation already, you can just have that with StackDriver. All your metrics will be ingested without a change. And if you're not using any Prometheus instrumentation yet, but you want to get access to third-party metrics, let's say you're using Kafka, RabbitMQ, or anything else on your app, then you can ingest those via Prometheus, and they'll be ready in StackDriver. So the way we do that is, if we want to inspect those metrics, we can create custom charts and custom dashboards, or you could go to Metrics Explorer, which is exactly the way you do on-demand type of inspection. So here we can inspect all of our Kubernetes objects and all the metrics that are available to you. I can look at all the Prometheus metrics. You see the autocomplete already expanding on all the Prometheus metrics. This is a Java app, so let's look into one particularly. Let's do the JVM memory use bytes to get a sense here. So, all right, there we go. So lots of signals, but fast and available, you get a sense for what we have here. Now, the good thing is that we've added a lot of dimensions to these metrics. So you can filter and group by a lot of metadata, including Kubernetes labels and user-defined labels. So let's try to do something here. Let's filter by service name. And for the service name, we can notice that you get actually an autocomplete of all the values that apply to that label. Let's do the API gateway. Apply that. OK, that's still a lot of signals, but a little bit better. We could still group by and aggregate, maybe create a 95th percentile or some sort. But what we have here is maybe the easiest thing would be maybe do outlier mode. We can then check the top N objects that are of interest. So why don't we do the top 5 containers by JVM memory use bytes, use memory bytes. So there we have it. So that rapidly you can easily develop a hypothesis or just inspect on demand and look at particular metrics for any of your Kubernetes components and metrics available. So this wraps up essentially this proactive type of monitoring. Now, all the other features in StackDriver, including multi-condition alerting and everything else, are available to you, including what you may have seen earlier in the keynote when it's ready for public consumption, all the service monitoring stuff and integration with Istio and so on. So that's essentially for the main console on Kubernetes monitoring. I'm going to switch with Shoshong now so that he can take us through a troubleshooting scenario.
All right, thanks, JD. So this is Shou Cong, the tech lead of StackDriver Kubernetes Monitoring. So I want to demo a troubleshooting scenario. So as a software engineer or operation engineer, one of the the common scenario you will probably encounter a lot in your daily work is when your application receiving a high volume of traffic, your application become less responsive or slow. And so this is the scenario. So to recall, it's like when JD is doing his demo, we generate some traffic against both Kubernetes Engine cluster and the on-prem cluster. And while you were watching the previous demo, I, as an on-call engineer, has been paged by this incident, by this traffic. So as you can see here from the email, I have already received an alert. It's like some of my containers are returning too many 500s. Some of my services are returning too many 500s. So, and in this email report at the bottom, it gives me a view incident link, which redirects me to StackDriver incident page. So as you can see here, so this is like our services are returning too many 500. This is concerning because our customer may is experiencing this outage. So I would like to resolve this incident as soon as possible. Let's go to the custom dashboard for my hybrid Pet Clinic app. This is a custom dashboard I predefined before. It adds some charts for some interesting metrics I care the most for my Pet Clinic application. For example, on the first row, there are two charts for HTTP requests and HTTP error rates. And since this is a Java application, so I also draw two charts for JVM metrics, which is collected and exported by Prometheus. Besides that, I also draw something like CPU limit utilization and memory utilization and some container restart and something else. So by looking at this custom dashboard, it should give me a very good understanding about what's my hybrid application, what's their current state. Let's look at the first chart. As you can see, both my Kubernetes Engine cluster and my on-prem cluster are receiving a reasonable amount of traffic, like both around 300. This is working as intended because this is what my load balancer configs. I put a half and half weight on both clusters. If we look at the second chart, we can see all of my 500 errors are all coming from on-prem cluster. It already gives me a very strong signal that something is wrong. It's in my on-prem cluster. As a natural reaction, I may want to dive deeper into the on-prem cluster and figure out what's happening there. But our SRE best practice tell me I should mitigate and contain the issue first. And the best choice here is to drain my on-prem cluster and fail over its traffic to somewhere else. And since I have two clusters, failing over to Kubernetes Engine is a natural choice. But before I do that, I want to ensure the additional safety. I want to make sure my Kubernetes Engine cluster can sustain the load if I double it. So let's go to the Kubernetes Monitoring UI. And let's take a look at the infrastructure and expand the Kubernetes Engine cluster. So as you can see, there are 6 nodes there. Some of them are reasonably busy, like you can see 42% utilized, 43, but some of them are quite empty. So this gives me a confidence that even I fail over my traffic to Kubernetes Engine, it can sustain. So let's go ahead and do it. So in this terminal, JD will manually drain the on-prem cluster by scaling down. And in the same time, we will switch back to Cloud Shell for my Kubernetes Engine cluster. And here, we will manually scale up to fail over the traffic. So this step will probably take about 1 or 2 minutes when we are switching traffic from one cluster to another cluster. Let's go back to the hybrid dashboard and see what we can observe there. So as you can see here, so our on-prem cluster traffic has already been dropped, and then the 500 rate is also dropping. And in a moment later, we will see the Kubernetes Engine cluster receiving more traffic. So let's give you a little bit more time. So in the real world, it's like draining the traffic will take some time. Okay, so let's refresh again. Okay, so let's further refresh one more time and see whether it can go. Yep, as you can see here, so our Kubernetes engine cluster has receiving more traffic, and it will keep going up. So I think in this moment, as an on-call engineer, I'm reasonably confident that the issue has been mitigated and contained. Now, next step for me is to figure out what's happening in this on-prem cluster to prevent it, to resolve it and prevent it from happening again. Let's go to Kubernetes UI, Monitoring UI, and switch to Service tab. And that's open. As you can see here, we have an incident, open incident count column that can give you an insight like what's the entity that has the most issues, and then it can help us drill down and then identify where we should pay attention to. So we can further go down to the default namespace. And there will be the API gateway. It's the thing that will have the issue. So let's inspect the port of API gateway. So as you can see here, so for the first try, it's container restart. It doesn't have any restart. It means probably my container is healthy. And memory utilization is in a reasonable usage. And CPU utilization is high, about 80%. But it is reasonable because we are sending a lot of traffic. And it is not crazy. It's not like out of the boundary. So it doesn't sound very suspicious. Let's scroll down, and then storage usage is flat. And network usage is high because the same, we are receiving a lot of traffic. So till now, if looking at the system metrics, it doesn't tell us anything like suspicious because it seems like my Kubernetes application, Kubernetes infrastructure is running healthily. Well, then what could be the root cause? At this moment, the log will help us a lot. As you can see here from the log rates, we are receiving a lot of unreasonable amount of error logs from what you have been. As you can see, there's about 40% of error log has been written during the incidents. This is a very good signal for me to maybe my app is returning has some bug, and then throwing some errors. As you can see from the log snippet below, we already see some runtime exception has been thrown by my Java application. I want to understand a little bit more details. Let's click on the go to logging link and then go to StackDriver logs viewer to have a more detailed look. So this link will redirect me to the logs viewer with the filter specifically for this single port and restricted to the time where this incident happened that matters the most to me. As you can read from here, there are dozens of occurrences of this runtime exception has been thrown. If we open one of them, we can see the error message is unable to fetch detail for owner one, which is a runtime exception, and it is a stack trace. It could give us a very good understanding where this exception has been thrown. If we scroll down, we can see this. So this API gateway controller. Let's see. Yeah, this API gateway controller Java file in line 54 is throwing this error. And I want to understand why this error has been thrown. Let's go to code. So what JD is doing here is he will search for this API gateway Java file, because that's what stack trace has tell us. And then let's go to the line 54, or use search. So as you can see here, there are 3 lines, very problematic. Somebody has added these 3 lines of code to throw 500 after tossing a coin. So this is where my code has a bug. And so I'm going to, so now I identify the root cause. The thing for me, next step is to fix the bug, redeploy the app to on-prem cluster, and then undrain the on-prem cluster. So my application will be back to normal. We are not going to do this here, but just to illustrate the idea. So as you can see from this arrow troubleshooting scenario, StackDriver Kubernetes Monitoring, it integrates metrics, logs, metadata, and events. It can give you the observability you need to monitor and troubleshoot your hybrid Kubernetes application. And let's switch back to slides. And so if you want to know a little bit more about how you want to observe and troubleshoot your hybrid Kubernetes application and how to provision your Kubernetes application better, here are some related talks you can attend. And now let's welcome back our teammates, Jesse and JD. Now we are open up for questions. And maybe the time is very limited. If you have more questions, we can go to the hallway. Thank you very much.
Thank you.